Hi friends, here we have to find how many 7-digit numbers that can be formed using the digits 1, 2, 3, but the sum of these digits should be 10. Right, we have total 7 digits only. We can use 1, 2, 1 or 2 or 3 and the sum of digits should be 10. Right, sum of digits means the value of the digits. Right, for example, if there are 4 ones, they will contribute to 4. And if there are 4 twos, they will contribute to 8. Right. Let us write the basic equation here. 7-digit integers, right? Total number of digits is 7. Let's say there are x ones and y twos and z threes, then x plus y plus z should be equal to 7. Right? Because there are total 7 digits. And sum of digits is equal to 1. What does that mean? There are x ones, then their contribution is x, and y twos, their contribution is 2y, and Z threes. That means their contribution is 3Z. This is the sum of digits, right? X plus 2y plus 3Z is equal to 10. We have two equations. Then let us subtract the second one from the first one. We get y plus 2z equals 3. Y plus 2z equals 3. Y means number of twos. Z means number of threes. Let us try to solve. When can see clearly y plus 2z equals 3. So z cannot be more than 1. Right? If z is 2, 2 2 is 4. There is y doesn't have any y y doesn't have any option here. Right? Z can be 0 or z can be 1. When z is 0, when z is 0, y will be 3. Right? When z is 1, y will be 1. We cannot have z equals 2. Then y will become negative, which is not possible. Not possible. What is that? Number of threes. Right? In this 7-digit integer number, we can have at most one three. We cannot have two threes. Right? If there are two threes, that will only contribute to 6. Right? And but there is no way to create a 7-digit integer. Right. If there are two threes, that will contribute to 6. Then we can at max take another four ones. Right. So that will become 2 plus 4, only 6 digits. Right. So there is no way we can take two threes. Basically, we can have zero threes or we can have one three. When it is zero threes, that means y is 3. What is y? We can have three twos. Y is number of twos. Right. 0 plus x plus y plus z equals 7. So if y is 3, then x is 4. Similarly, z is 1, then y equals 1 and x plus y plus z equals 7. So x equals 5. So basically, we have two options here. Either you create the number, 7-digit number with four ones and three twos, right? 4 plus 6. That will become total 10. That will work. Or 5 ones plus 1 2 plus 1 3. 5 ones 5 plus 2, that is 7 plus 3 10. We have only these two options. Right. Now this problem is equal to this. We have 7-digit number with four ones and three twos. What is the number of? Because it is like 7 digits have to be arranged, of which four are same and another three are same. So what is that? 7 factorial by 4 factorial into 3 factorial. It is like arrange n objects, of which p are P are same and Q are same. P are exactly alike, Q are exactly alike. That is n factorial by P factorial into Q factorial. Right? We have seven objects here, seven numbers that we can arrange. If everyone is different, we would have got 7 factorial. But here, 4 are same and another 3 are same. So it is 7 factorial by 4 factorial into 3 factorial. Right, we all know this. N factorial by P factorial into Q factorial. Why is this? Right, please comment. Right, you all should know this. When when in a collection of n objects or in a collection of seven objects, if four are same and three are same, it should be 7 factorial by 4 factorial into 3 factorial. Right. Similarly, this is again collection of seven, of which five are same. Five are same. Right. 1, 2, 1, 3. It doesn't matter. Which five are same. So this would give rise to 7 factorial by 5 factorial, which is 42. Right. So total is 35 plus 42, which is 77. One important thing that we should note here is if there are n objects or n things which can be arranged among themselves. If all are different, we would get n factorial. But of this n, if some p are same, then the number of options or number of arrangements will reduce to n factorial by p factorial. If there are p same elements and q same elements, then n factorial by p factorial into q factorial, like this. Right? You should know this formula as well as the understanding behind this. Please comment below the video. Right. So, for example, let's say the seven-digit integer only with four one same and three two same. This now we have found it is 35. Let's say it is x. Right. Seven-digit integer or seven elements and four are same and three are same. They can be arranged in some x ways. Right. Let us don't know. Let us assume we don't know this formula. Then if of this three of the three that are same, if they are different, they would have contributed to x 3 factorial more ways. So right, if they all three were different, then this would have become x into 3 factorial. Now, and if the remaining four were also different, this would have contributed to x into 3 factorial into 4 factorial. Right. That means if all three were different, all four were different, this would have given x into 3 factorial into 4 factorial. But that means all seven are different. All seven are different should be equal to 7 factorial. Right. So x into 3 factorial into 4 factorial is becoming 7 factorial. So x should be 7 factorial by 4 factorial into 3 factorial. Right. This is the derivation or this is the understanding why when given some n objects of which some p are exactly same and some q are exactly same, the number of arrangements will be n factorial by p factorial into q factorial. Right guys? This is an easy problem. Just that we need to be able to write these equations and then it is pretty straightforward. Right guys? Thank you.